Hello, my name is Dan Nissen, and today we are going to be taking a look at how to render particles inside of Redshift for Cinema 4D. Now I want to preface this before I start, this tutorial will not be showing you how to set up these scenes. However, I will show you how to render 3 different types of particle setups that include rendering particles from Houdini, the native particle system inside of Cinema 4D, and as well as X particles. With these different setups, I will also show you how to use the different attributes that can be very helpful during the shading process. So let's go ahead and get started. Okay, to start off, I'm going to be importing some particles from Houdini through an Alembic file. Now I won't be showing you how to export these particles, as I just won't have time today, but if you do a quick Google search, you should be able to figure it out. So we're actually going to go to File, and then Merge. And we're going to locate our .abc, which is basically our Alembic file. So let's go ahead and open this up. And we actually have some import settings. So we want to change this frame rate to 24, because that's what I'm working with inside of Cinema 4D today. We want to raise the scale to 5 just for our specific scene. And we want to make sure that points is checked on and that we're bringing this in as particle geometry. Once all that is good, we're going to hit OK. And we want to make sure that we're starting our animation at frame 1. So let's go ahead and press play. And as you can see, we now have our particles in our viewport. Now, if we actually bring up our render viewer and activate our IPR, which I already had running for some reason, you can see that nothing is actually showing up. Nothing is being rendered. And I'll explain why in a second and how we can fix that. But for right now, let's actually take a look at some settings. So if we go to our particle geometry tab, and expand this particle group, we have a few settings here. So if we activate use color, and say for some reason that these particles are hard for you to see at their current color, we can adjust this here. So like a neon blue, maybe it's easier for you to see. And we also have some different particle types, so we can change this to ticks, and you can see what that's doing. Or we'll go like to drops. And yeah, you can see the effect that is having. Now, this is strictly just for the viewport. This will not be affecting your render at all. So yeah, let's actually take a look at some more settings now. So if we go to Simulate, and we don't want to go to the Particle tab. We actually want to go to the Thinking Particle tab, and specifically the Thinking Particle settings. And the reason we're doing this is Cinema 4D is actually converting our Alembic particles into thinking particles. And this way, it allows us to use the attributes through the thinking particle channels for basically shading or stuff like Pscale, which is going to be affecting our overall scale for our particles, which we'll actually be looking at later. So that Cinema 4D automatically converts this for us, which is pretty convenient. So let's actually go ahead and close this for now. And how do we get these rendering? How do we get these showing up in the render viewer? Well, it's actually quite simple. So we're going to go to our sphere object 1. And we're going to right click this, and we want to add a Redshift tag. So we're going to go and add a Redshift object tag. And basically this is going to be telling Redshift that, hey, these are particles. And once we've done that, we now have a particle tab. And if you see, we now have some different modes that we can use. So we go ahead and click point instances, and let's actually turn on our IPR just so we can get some real-time feedback. And I know this scale is already going to be too big. So let's go ahead and lower this, and the scale multiplier is pretty straightforward. Higher the number is, bigger they are, smaller. I think you get the point. So if we go ahead and activate our IPR, you can see we are now getting something rendering in our render view. So if we actually go to our close-up camera to see what's actually happening. Basically, this point instances mode is basically like disks. And if we go to the different modes, we can do sphere instances, which are now, they're rendering as spheres. Quad instances, which is basically like planes. And then we have custom objects, which I'm sure you can guess what that is, but we'll look at it in a second. And we have one more sphere mode. Now you might have noticed that this spheres mode and this sphere instance mode, which I'll switch back and forth between the two, there's no actual visual difference. Now, there is a technical difference, though, and it's actually a pretty big one, so I want everyone to pay close attention to this, because it's actually something that's been pretty misconstrued that I've seen. So and I'll admittedly, it was, I didn't understand it at first either. I had it wrong all along as well. So the actual spheres mode is actually Redshift's native point primitive, while the sphere instance mode is basically like it's a sphere mesh that's generated in Cinema 4D and then instance with Redshift. So the spheres mode that we have activated right now is extremely beneficial because it's extremely lightweight, and it's even more lightweight than an instance, and it can go out of core. Now, basically, you already know that instances are bound to basically the RAM on your video card, so you can run into issues if you're on extremely high counts of particles. So it's always highly suggested to use the spheres option that I have right here, the bottom option, whenever you're using extremely high counts of particles. So yeah, that's something that I don't think a lot of people know about, and you would automatically think that sphere instance, instance is, it's a kind of a way to optimize your scenes and stuff, but no. And when it comes to this, the sphere mode is the most lightweight option. So let's actually take a look at the custom objects mode. So we bring in some different objects. So let's bring in a cube, and I'm gonna go ahead and lower the scale. And let's actually we actually have a drag and drop box for our custom objects. I'm sure you can guess what's gonna happen. We drag the cube in there. We're now getting cubes rendering throughout our particles. And if we bring in another one, so let's bring in a platonic and change the scale of this, and we'll drag this in, you can see that we're now getting cubes and platonics rendering. And of course, we can play with the distribution, so we can go to random and then play with the seed here. And yeah, now this is just the different effect that we're getting. And if we zoom out, you can see what that is looking like. And as always, we can go back to our sphere mode, which we're actually going to be using for the rest of this tutorial. So I can go ahead and delete these. And that's how you can get particles rendering inside of Redshift. Next, we're going to be taking a look at how to actually shade these particles. Alright, so let's go ahead and create a new material. So let's go to create Redshift materials, and we actually want to bring in a particle material, and let's apply this to our sphere object 1. Now this material actually isn't anything special. If we bring up the shader graph, you can see that it's actually just a normal Redshift material with a color user data hooked up to the diffuse. Think of it as like a preset, it's just saving us a few clicks. So what we actually want to do is we want to change the attribute on our color user data node. So if we go to the arrow, and you can see at the bottom we have TP data channels, and we actually want to change this to CD. Now what we want to do is we actually want to remap this with a ramp. So if we type in ramp and bring in a ramp node, and what we'll do is we'll actually plug our color user data node into the input, and then plug the ramp into our diffuse color. Now, like always, we need to change the source to alt, and now we can pick two. We'll pick two contrasty colors just to really see the effect. So like a neon blue, and we'll do like a yellow almost. Oops, let me bring this over here for you, and we'll do like a yellow. And let's actually bring up our IPR so we can see some of these changes. And as you can see, we are now getting these effects coming through. We have our yellow particles and then our kind of lime green, lime blue particles coming in. And we just scroll through our timeline. You can see the effect that it's having. And what we can actually do is, we can bring in any nodes that we want into our shader graph. This is just a normal shader graph like always. So we can bring in a change range. And what I'm going to do is I'm going to plug this in between the user data node and the ramp. So let's plug this into the input, and then this into the ramp. If I bring this just over here, get a little bit organized, what we can start doing is basically we can start either crunching or softening up these effects out of our ramp. So if I bring this range max down, say to 0.5, you can see we're getting less of that yellow now, and more of the green is coming through. And at the same time, say we, we'll put this back to the normal one so you can see. Say we raise this to about 2.5. We'll go even higher, we'll go up to 5. You can see more of that yellow is coming in now and less of the green. And these values, we don't have to pipe this into diffuse color. This can be piped into the reflection color, even the roughness, it's normal shading stuff. So actually, let's take a look at some more user data nodes. So I'm gonna go ahead and type in data, so just so I can easily access these nodes, and we're gonna bring in some integer, and then the scalar, just so I can show you guys. So if we go to our integer user data node and click on the arrow, you can see all the different options we have to use for the integers, which we won't be needing that for shading. I just wanted to show you. But we do want to use some of the scalar user data attributes. So if we go to the thinking particle data channel, so you can see all the different options we have. And we want to click on age. And what we actually want to do is basically all the scalar data nodes can be remapped with ramps. And I'll show you that right now. So we'll bring in a ramp node, just like we did before with our user data, with our color user data. And we'll plug the scalar into the ramp. General input. Remember, always change the source to alt. And then we want to plug this into the diffuse color. And we're going to go to the beginning of our timeline, and we need to choose some colors here. So let's get like a pure red. Let's get some Christmas colors in here. And yeah, there we go. And basically what this is doing is, remember, we brought in the age attribute from the scalar data, and basically the way this is going to work is the older the particles get, they're going to shift in color. So you can see here, according to our ramp, we have our red. So basically they're being born, they're turning red, or they're red when they're born basically. And as they get older, so let's progress our timeline a bit, you can see that they're starting to turn green. And if we just keep bringing this farther along, you can see that they're primarily all green right here, but you can see there's a few particles down here that are just now being born that are red. And we just go through our timeline a bit more. Let's get to a better spot. Yeah, and you can see, you can see the effect that that's having. And this ramp, you can put as many colors as you want. So, we'll just add a blue. We'll add a pink. We'll add a kind of a yellow. And let's go back to the beginning of our timeline. You can see the effect that this is going to be having. So basically, as they get older, they are shifting in color. And you get this really cool effect. And yeah, you can see what is happening there. Of course, you can shift any of these colors to whatever you want, You can go back to using the CD vector for shading. It's completely up to you. The possibilities are endless. Okay, now I'm going to show you how we can use Pscale from Houdini inside of Redshift and Cinema 4D. Now, it's a bit different from what I've been showing you so far. It is using Espresso, but don't worry, it's a fairly simple setup, and I'm going to show you how to do it. So before we do that, you might notice in our IPR, all the spheres are pretty much the same size, They're abiding by this scale multiplier of 0.01. So once we add the Pscale, you're going to see a different effect happen. So basically, we're going to right-click our sphere object, go into Cinema 4D tags, and we need to add an Espresso tag. And basically, this is going to bring up our Espresso editor, and we need a couple nodes. So we need the particle pass node. So we're going to go ahead and drag this in. We're going to need our get data node. And we're going to need our set data node. Now we click on this particle pass. Let's bring up our custom and then thinking particle settings. And we actually need to grab this sphere object 1 and drag this into the group. This is basically telling the Espresso what thinking particles we're affecting. Go ahead and close this. And we can go ahead and connect this particle pass into the particle slot on the get data. Now for the get data node, we need to expose the Pscale. That's the data that we're going to be needing. So the Pscale real. And then we need, on this set data node, we need to expose the size, which is what we're going to be affecting for each and every individual particle. So we plug this Pscale into the size, and then plug this P-pass, the particle pass, into the particle slot. And then you're done. That's all you need to do. We might need to reset our IPR for the changes to come through, but we can go ahead and close this Espresso editor, and we might need to change the scale multiplier as well. but we'll see. So if we actually restart our IPR, yeah, you can see they're quite small now. So we'll bring this up a bit because it's taking data from Houdini, so the scales might be different. And if we go through our timeline, you can see that you can see that we're now getting some smaller particles. And let's find a good spot so I can really show this. Okay, here we go. So you can see the particles at the base of our sphere are quite big, but then as they get farther out, as they travel farther distances, they're getting smaller, and that's the way I set up my Pscale inside of Houdini. And now we're getting this effect inside of Redshift as well. So it's extremely powerful. And if you notice as well, I have the age set up as well on the color. So the older they get and the farther they travel, they're changing color and they're changing size, and it's quite a cool effect. And we just go to a different spot on our timeline, and yeah, you can see the effect we're getting. And if you go back to the beginning, you can see they're all pretty much the same size, and as they get older, they're starting to shrink, and they get quite small. And yeah, that's how you add Pscale to your particles inside of Redshift. It's a really powerful effect that's extremely useful. Okay, so I know this tutorial is primarily about rendering particles inside of Redshift, but I'm going to briefly go over the settings for motion blur. So first and foremost, we want to make sure that we have an object tag on the object that we want motion blur on. Because we're already rendering particles, we already have one on. So we go to this tag, and we want to go to the motion blur tab, and we want to check this on, and we want to use global settings. So now let's actually go to our render settings and take a look at our motion blur options. So go to Redshift, Basic, and then you see down here the motion blur. And so now I'm going to briefly go through each and every option we have here and just basically tell you what it's doing. So obviously we're going to enable motion blur. And then for the next setting, so enable deformation blur basically is for if you have velocity data for your motion blur, which we don't have today, so we can just keep that off. We don't need that right now. Transformation steps basically is going to increase the accuracy of your motion blur, but it will use more memory. A default of 2 is fine for what we're doing today, so we're leaving that at default as well. Now the frame duration. Basically the way this is going to work is it's simulating what's happening in the real world when a shutter from a camera is staying open. So when a shutter from a camera is staying open longer, the blurrier the result you're going to get, basically. So the same with the frame duration. So the higher this number, it's going to be the blurrier the result. So we're going to use a pretty high number just so we can get like a very strong effect. So we'll do like 2.5 is good. So now for the shutter start and the shutter end, basically the way these are working is the smaller the differences between the two, the shorter the blur is going to be, and then vice versa. But we're just going to keep those at default for now. And same with the shutter position, we're going to keep this at center on frame. Now, if you do need like a detailed description of all these settings, you can go in the Redshift docs. You know, they have great examples. Honestly, I suggest just going into Redshift and making a new scene and having a really simple like sphere bouncing up and down and just play with all these settings. That's the best way to learn it, in my opinion. But yeah, and then the last setting is the shutter efficiency. We're going to put this about 0.25. This is basically going to like soften up our motion blur. So now let's actually render our motion blur. Now, a common mistake that most people make is, you know, they'll hit render and their IPR like, oh, I'm not getting motion blur, or they'll do a bucket render and be like, oh, my motion blur is not working. Well, the motion blur is only working in the final render. Right now, we're in the IPR. Even though we're using bucket, we're still in the IPR. You know, we're using this option right here. See, it says start/stop IPR. So we need to do a final render, basically the very leftmost button. So we're basically going to click this, and this is going to get our motion blur working. And while that's rendering, I'm actually going to bring up something I did the other day, basically just testing stuff. And here is the motion blur I was using, or I was trying to get. And I'll go to a nice frame. So like right here, you can see we're getting some nice motion blur here. I can kind of see at the bottom, this timeline's in the way. You can see at the top we're getting nice motion blur. And yeah, you know, it's honestly a really easy effect to get. It's, you know, it doesn't cost anything when it comes to rendering. And it's just an overall nice effect. So let's see how our render is doing. And yeah, you can see we're getting a pretty strong motion blur effect, especially on the sides where it's moving faster, and on the top and bottom. And once again, if you are getting, we are getting a bit of noise here, which we're just doing some look dev, so my settings aren't the best optimized or the highest right now. But you can always just adjust the unified sampling to clean up some of that noise. So yeah, that's motion blur inside of Redshift and Cinema 4D. Alright, so I've pretty much shown you the beef of the tutorial, all the main points of, getting particles to render inside of Redshift, shading with different attributes, applying Pscale. Now I'm just going to show you on some different types of setups. So we're still working with particles. I have a normal Cinema 4D emitter with a turbulence applied, and if we play this, you can see it's basically just like an explosion or like a dust cloud. And if I bring up the IPR, I can show you what this looks like. And, as you might have noticed, this setup is no different than what we were doing with the Alembic file. We have an object tag applied to our emitter, and I'm using custom objects. And something I didn't mention earlier, which is actually nice about using the custom objects, is you can use different shaders for each object. So you can see two of the objects here, the pyramid and the cube, I have applied a more of a matte material. And then on the platonic, I have a bit of a shinier material, and that's just going to get some different variation in the shading during this animation. And yeah, and as you can see, this the setup is not any different. It's pretty straightforward. It's the same concept, same theory, same workflow. One thing to note that I didn't mention earlier is if you have the ability to cache your particles, I 100% always suggest caching your particles. It can lead to issues of like the IPR not matching the render viewer when you go to render. It can run into issues during, if you're using motion blur. You can just run into some weird stuff if you're not caching them. So if you have the ability to, I suggest always trying to cache them. Alright, so I'm going to show you one more setup, and that's going to be rendering X particles inside of Redshift. Like I showed you before, it's pretty straightforward. We have our object tag applied to our XP emitter. We're using the sphere mode once again because that's the most lightweight. It's the best option to use when you're rendering a lot of particles, which I have a ton here. And we're using a 0.5 scale multiplier. And I'll actually pull up the render viewer to show you what this looks like. And yeah, now I'm going to show you how you can set up a material with the X particles attributes real quick. So let's go ahead and create a new material under Redshift materials and then particle. And let's go ahead and pause this for now just so we don't get any stutters because I am recording. So let's bring up the shader graph. And once again, you guys know that this is just a regular Redshift material with a color user data node. And once again, we're going to need a ramp to remap these colors. So we're going to plug in the color user data node into the ramp under general input and then input. And then plug this output into the diffuse color and change the source to alt. Now, the way this particle color material is set up, it is actually on the right attribute for us for X particles. So we go to particles and then particle color. So that's exactly what we want. We don't have to touch that. And let's go ahead and bring in some different colors here. So we'll add like our purplish, bluish color and like a gold. And let's see how this is looking. And if we're rendering that now, we are now getting some different color variations. Just like I showed you before, we're using the attributes by going to the arrow and then seeing the different options we have. And like before, if we bring up some different data channels, so we bring in some, we'll bring in the scalar user data. And let's actually go to the attributes at the arrow, sorry, it's hard for me to say, and look at the different particle options. We have age, live, age normalized. We have all these different options that we can use for shading. And the great thing about the scalar user data is it can be remapped with ramps very easily. So if we're going to use the age normalized. Let's actually bring in another ramp. And once again, we're going to hook the scalar user data up to the ramp into the diffuse color. We need to change the source to alt once again. And let's just start adding some colors into this ramp. And remember how I showed you before how the age works? It works no differently inside of X particles. So I'm just going to add some random colors. Let's try to get like a nice spectrum of colors. I want like a pink reddish color. We'll get like a, I don't know, like a tan color, and then we'll end on like a yellow. Just a nice wide spectrum of colors. And we can actually right click this and then do distribute knots, get them all evenly. And let's actually go ahead and pause our IPR and go back to the beginning of our timeline. And let's just play this for a bit so I can show what this age normalize is actually doing. And we'll pause it there. And as you can see, working from our ramp left to right, they're born and they're that green color, and they're starting to become blue, and then they're going to transfer to that pink red. And if we zoom in, you can see them start to transition, that gradient happening to the red. And if we actually just pause this and then play it a bit more, and sorry if it's moving slow, I am recording and rendering all at the same time, and this is some pretty heavy particle stuff. So let's hit the IPR again, and yeah, you can see we're just getting that nice color variation. You know, it looks really nice. And we can take this even farther, so we can start getting the end of the colors. And basically, it's gonna move throughout the spectrum of colors, throughout the ramp of colors, till they basically like once it hits this yellow color, they're basically gonna stay that color till they die, basically. And we fire this up again, then we're gonna get this nice spectrum of colors. You know, just overall really nice effect. Alright, before I go, there's one more thing that I forgot to show you inside of X particles and Redshift, and that's how to render the trails inside of X particles. So if we just pull out this very simple setup, you can see the trails going, and I think it's turbulence, yeah, it's noise type curl, just in all different directions. Very basic setup. And how to get these actually rendering inside the render viewer. So if we go there now, you know, they're not actually going to be showing up. What we need to do, like before, is right click our, whoops, not the right one. We need to right click our XP trail. We need to go and add an object tag, and this is going to add the curve option to our trail. And basically this has different modes as well, and I'm not going to go through each mode individually. You can probably guess, or you can zoom in what they're going to look like on your own, but I am going to select the cylinders. And if we actually go to the render viewer, we're now going to get something inside of here. So while this is extracting and preparing, there we go, bang. We're getting our spaghetti wires, whatever you want to call them, rendering inside of Redshift and X particles. And I'll go over some of the settings real quick. You know, the thickness, basically how thick they're going to be. We can create this to 2. And then what this scale is actually doing is, right now it's basically linear. You know, it's a 2 thickness all the way throughout the entire trail, basically. Well, with this, basically we can create like a taper. And sorry, it's slowing down on me while recording. Let me actually pause the IPR real quick. And then we can move this down, and it's basically going to be tapering the ends. So we could do this all the way down to basically 1 or 0 actually. And this is basically going to have the end go basically start at this 2 and then go all the way down to 0. But we still want a little bit of an end, so we'll put it about right here. And you can see the effect that is having in the IPR. And you'll start to see the ends basically get thinner while this is loading up. And there we go, yep. And that's the effect we're getting. And that's how you render XP trails inside of Redshift. You know, it's not much different than the particles. Same tag, just a little bit different settings. And you can try out some of these different modes on your own if you want. And we'll do stripes right now, just to see what it looks like, see if it looks any different. Might look a little bit flatter. Yeah, we're getting a little bit flatter result. Almost looks like hair, to be honest. And yeah, that's how you render XP trails inside of Redshift. I hope everything was easy to follow, and that by the third example, you have a better understanding about rendering particles inside of Redshift and Cinema 4D. Make sure to subscribe to the channel for more Redshift tutorials and content.